Look, a train is slowly approaching in front of us. Normally, it should be going in a straight line along these two tracks. But I want him to turn right along the two tracks on the right. So how do you do that? This requires the use of the track switch system to enable the train to change tracks. The original turnout system was manually operated by workers. It is driven by a series of iron chains under the switch machine, which operate the nearby link mechanism. Thus, it moves the switch points in the track switch to make the train go to different tracks. The train changing tracks seems simple, but it's quite complicated in actual operation. First, look at this train wheel. When you can't predict which track it will roll on, then you can watch this experiment. If train wheels were flat like car wheels, when it turns the track, it will fall off. If it's narrow on the inside and wide on the outside, it's not as good as a flat wheel. So the engineers designed it with a tapered shape, wider on the inside and narrower on the outside. Although this design allows the wheel to travel farther than on a flat surface, it still slips off the track when encountering a large turn. We can add a side to the inside of the wheel. Don't underestimate the small raised flange. It gets stuck inside the track. It can not only prevent the train from derailing, but also guide the train's direction. Now let's go back to the previous question. Which track will the wheel of this train roll to? With the guidance of the flange, its direction is clear. What if I want the wheel to go to the left rail? It's actually quite simple. Just split the track in half from here. According to this concept, we simulate that when a pair of wheels of a train roll in sync. We can achieve this by simultaneously moving both switch points to guide the direction of the train, whether it's changing tracks to the left or right. It seems to be fine, but in reality, this design of track is not feasible, because at the intersection of the two tracks, we'll catch the raised flange of the train's wheels, causing the train to derail. You, being clever, would surely think that's quite simple. The solution is to be at the intersection of the two tracks. Make a gap, so that the raised flange can pass through. But this design will bring new problems, just like digging a hole in a flat road. Although the car can pass through, it's bumpy. To solve this bumpy problem, we can extend the rails slightly on both sides of the crossing. With the support of the extension, the train wheels will no longer bump, but it brings new problems. When the train passes through the extension section, it might lead you astray, rolling to the other track, which will cause the wheels on the other side to derail. So the guardrail was introduced. Its function is to guide the train wheels to the designated track. Because the switch rail is the point of force, it wears out more quickly, so it needs to be replaced regularly. And now the turnout system is intelligently networked motor control. Movement of the switch points no longer requires manual operation by the switchman.